Welcome to LIS754 Systems Analysis and Design, and in this session we are going to talk about the specifics of the specifications document. We're going to define specifications, think about the goals of this specification, and look at the specific elements that are necessary to have an effective specifications document. A systems requirement specification is an official document, an official statement of what system should be developed. It should be a complete description of the behavior of the system. We want to be very clear and precise and complete in what we say that this new system needs to do. We want it to include user requirements and specifications of the system requirements. We want to have a full description of what the software will do and how it should perform. Now, in most organizations, when a specification is being written, there are a number of people who work on it. There are people who work on the user side, and there are people who work on the system side. And in our case, in this course, we have really focused on the user requirements. There are other courses that you could take if you're interested in the hardware requirements, the system kind of requirements. But in this course, we're going to focus, and in our specification document, we are going to focus on the user requirements. So like many of the components that we've been working on over the past semester, this document is a communications medium, just like the process model, just like the use cases, just like the project plan. All of these kinds of documents are really important to communicate the process, communicate the requirements to the people who are going to develop the system, to the people who are going to use this system, to the management of an organization. And we want to, again, be precise in the product so that everyone understands what's going on. As we talked about very early in the semester, there are many projects that have failed because of a gap in communications. The people who understand what it should do and the people who create the software have not effectively communicated. And our goal with this specification is to be able to effectively communicate what exactly the problem is, what exactly the solution should be. So we can get feedback to and feedback from the stakeholders in this system. So when we create a specification, what we're often doing is creating what's called a statement of work, sometimes called an SOW. I have never heard that pronounced as a word, but always the letters are pronounced, an SOW, a statement of work. And we use this often internally between departments in an organization or between teams in an organization. Or even within a team in an organization. So a business or a school or a library can have a development team, and that can include analysts and programmers. Sometimes they're separated. There's a team of analysts and a team of programmers. But regardless, even internally within a team, having this kind of clear statement of work is really useful. It's exceptionally useful if the software development is going to be done by an external organization. And so often software development is outsourced, and sometimes it's outsourced to consulting agencies that work primarily in the US, and often that company will have additional resources overseas. So India and China and our primary sources of additional programming staff. And when we contract externally with a consulting agency or a software development organization to develop our systems, this statement of work, this specification, becomes a contract. It becomes any mistakes, anything that isn't clear causes significant problems. It also becomes a budget. So the consulting company will take this specification, they will apply a dollar amount and a time value to each of the requirements in the specification, in the statement of work, and it's now fixed, right? We have a cost, we have a set of functions, and it's contractual. So if mistakes are found, or if we did not do a good enough job in our specifications, we find new requirements, it becomes every step of the process, as time goes on, those changes become much more expensive and much more difficult to incorporate into the process. So we want to make sure that when we're doing, especially if we're going external to an external company, that we are really clear and really sure of our specifications. So the users of this requirements document are systems customers, the people who are doing the development, managers who care about how this is working, who are planning the bid. We have engineers and testers and systems maintenance engineers, all of who use this requirement for different purposes, to understand what the system is to develop, how we are going to test and validate this system, how we are going to maintain this over time. All of these people care deeply about it. So how do we develop a document that's really useful? So there is an organization called IEEE and ANSI, the American the standards organizations. I'm going to start this sentence again. There are templates for creating requirements documents, for creating specifications. And the Department of Defense and IEEE, which is, for those of you who don't know, the Institute of Electrical and Electronics Engineers. And IEEE is one of the largest professional organizations for computer professionals. There's journals, they have conferences, all sorts of things. It's a really large organization, and if you're interested, you can look them up. They're totally an interesting group. Has developed a standard for requirements documents. It's the IEEE ANSI 830 1998 standard. Now, that seems like a long time ago, 1998, and it is. It is still the accepted standard. It is still the format that IEEE and ANSI recommends in their Guide to Software Engineering, which is a totally interesting document. So I would, if you're interested, encourage you to take a look at this. It's really interesting to look at. So here is the requirement structure from that IEEE ANSI document. First is an introduction, a general description, system features, and external interface requirements. So this is the structure I would like you to use in your final document. An introduction, a general description, system features, and external interface requirements. So let's talk about what those are. The introduction is describes the purpose of the specification, not the purpose of the software. But this document, your specification document, is to be used by whom in your organizations for what purpose, right? You're talking about the purpose of the specification. In the next section, in scope, now you're going to start describing what the software will and won't do, the application software, the benefits, the objectives. And you've worked on some of this in your initial project plan. You may need to make changes to that depending on where you've taken it during your process, but you have you have the start of a scope based on your initial project proposal. It's very helpful to define definitions, acronyms, abbreviations. Some of you in your projects are writing for a very, very specific organization. You have a lot of acronyms. Please define them. Think of writing this to people who don't know anything about your business. So if you were going to do this for an external contractor, you would need to describe all of these acronyms, right? You would need to make sure that people really understood what your software is going to do. This is what you, that's the goal. So define this well. If you are going to, there is not a lot of need to have external references, so we don't need to have references to all of the readings from the class, but if there are specific documents that you are going to refer to, so if you are working on a system for a governmental organization and there are existing documents that you are going to refer to, please list them in there. But it doesn't have to be like the readings from the class, just external documents that describe your system. And then clearly an overview, we need an overview of the rest of the specification. So basically how you are organizing the document. Then there's the general description that talks about the perspective of the product. Is this an independent product? Is it part of a larger system? Is it new to the world? Is it a significant modification of an existing system? You're going to talk about the product functions, the summary of what it's going to do. And this is a place where if it's useful, you can have high-level diagrams. So perhaps your process flow might fit in here, perhaps a higher level view of the process flow, or some kind of a diagram that helps understand the relationships can be useful, and user characteristics. So describing the people who are going to use this. And when we talk in the next session, we're going to have next week we're going to talk about security. So this will be a place where some of your security functions will go. Constraints. What are the things that you know are going to be are decisions that have already been made? So for some of you, you're going to want to work in the Google suite of products. Others of you may need to run under Windows. Maybe you don't have that. Maybe you don't have constraints yet decided at all, and that's fine. It doesn't need to. But you could have other constraints. So just document them there. If you have assumptions and dependencies, that is assuming that you need to get data from, say, the registrar's office, or get a data feed from another part of your organizations. You might want to put something like that in there. And then we want to have a way of saying what is the most important things that you are going to do. So if there are functions that you could delay for future versions, or things that you know that you're going to want to add later that aren't part of this project, you can put them in this section. Then you're going to use the system, you're going to define the system features. You are going to identify a system feature and describe it, give it a priority, action, results, and functions, and then system feature 2, etc. And these are very similar to your use cases. So this is, if you've done a good job on your use cases, this will be pretty straightforward to fill in. And so here it is. We would say this is an example from a system that I developed a couple years ago. Keyword searching for this system. I needed to be able to search all of the data based on keywords. It's a top priority, required for first release. The user enters a term into the input box or boxes. The system responds with search results that match that term, regardless of where the term appears in the record. That's it. So straightforward. We're going to do 1, 2, as many as you need to describe your system, because this, again, is what is going to be developed. Here's an example, function 2. And many of us will have this in our systems that we're developing in class. Adding a new user, top priority. A user adds a name, first, middle initial, last name, address. Uses zip code to fill in the city and state. Phone number, uses NNN, NNN, and NNN format. So I'm describing exactly how this system should work, right? I'm describing, I want that the first, middle, and last name are all required, or that are specifically laid out. How the address function should work. I want to not have to have people type in city and state. If they use the zip code, it should fill in. The mask for the phone number, a user ID. The more details you add, the more clear and the less ambiguous your system requirements will be, and the higher the probability of success. So I even put in what the response. The system will send a message, user ID created successfully upon success, error messages, and I could have added error messages here too. Details are really useful. And external interfaces are required. And so what does that mean? Well, one is the user interface. How will people interact? So screens and processes. Hardware interfaces, if you have them. So for some applications, you might use a barcode reader to get data in if you were doing some kind of a point of sale system or a library system where you had, we're going through and using a barcode reader to check the barcodes on the book. Or if there is some kind of unusual hardware interface. If you're using browsers, you don't need to necessarily put that in. Some of us will have interfaces with other software systems, and we want to talk about how that, what data, what kind of interfaces need to happen between different systems. So if you're getting data from the registrar's office, you're getting data from the accounting office, you're getting data from some other part of your organization to go into this system, you need to talk about that in this section. And if there's any special needs for communication protocols or interfaces, you don't need to fill all of these in if you don't have them. You can remove these sections or not address them. That's fine if it makes sense for your system to. If your system does not need them, you don't need to include them. If your system does need them, you do need to include them. So you will need to make that determination. So let's just briefly review the characteristics of what a good systems requirement document should be, a system specification document. We really want things to be correct because, again, making a mistake is costly in this process. So we want certainly to make sure that things are correct. This one's a little more tricky because we want things to be unambiguous. So that means we have to write it in a way that there can be only one interpretation. So that's why in that user requirements number 2 that I described briefly a moment ago, I added those things like a mask for the phone number, how I wanted the names, people's names to be described, how the user ID should be formatted, what kind of error messages should be created, or what does a success message look like. It makes it less ambiguous when we put that kind of detail in. So we can do that by be unambiguous when we add enough detail to make it clear. Certainly we want it to be complete. We want it to be consistent. So we don't want to have, it's a different kind of error, right? So being inconsistent is a type of error, but look for internal consistency. So if your process flow says that the data from the registrar's office is going to be processed in one way and your requirement has it processed slightly differently, that's going to be a problem. And then, of course, to rank the requirements in terms of what's essential, what must be done for the day 1 release, and what is desirable. And we do that because often time is of a premium. And so if someone has to decide how what features to cut because we don't have enough time to finish it, it's really great if that is done beforehand, and people can prioritize the important tasks. We want to make sure that our data, that our requirements are verifiable. So we can verify things like that the first and middle and last names are captured. We can make sure that we can check that the requirement that the zip code will fill in the city and state. We can't verify things that are emotional. We can't verify things that are feelings. We can't but we can write requirements that are verifiable. People should be able to do this task in this way. We might put in verifiable requirements in terms of time. We might say people should be able to get a response back from the computer in 2 seconds. But we need things that are verifiable. And so part of that is being specific. And it's all about being specific, not just part of it. It's all about being specific. We want to be able to make requirements that can be modified if necessary. Again, that just can cost time. And we do want to be able to, just like we did in our use cases, be able to trace requirements. So there will be more videos on the Canvas site. This is an overview of what a requirements document should be and include. Please let me know if you have questions. Talk to you later.